The neuron is the most fundamental unit of the brain. There are around 100 billion neurons in every brain, and each of them can fire at up to 100 times a second. Every time you move your hand, or speak, or taste food, your neurons are lighting up and firing, sending signals all around your body and to one another. Now, by now, you've probably noticed the title of the video, and don't worry, we'll be discussing lots of fun chemicals later, but for now we need to cover the basics of neuroanatomy. There are 3 types of neurons: sensory, motor, and interneuron. Sensory neurons pick up signals from your sense organs like your ears and your nose, and also from your skin, your muscles, and your joints, and then sends those signals to the central nervous system. Within the central nervous system are the interneurons. The interneurons take those signals and give them to motor neurons. Sensory neurons and motor neurons never interact. They always have to have an interneuron in between them. Motor neurons then accept those signals and send them out to muscles and glands, which react accordingly. This is what a neuron looks like, although much smaller. There are a few basic parts of the neuron: the cell body, also called the soma, the nucleus in the middle of the cell body, which controls the entire neuron. These stringy parts branching off of the soma are called dendrites, which are very important for receiving signals from other neurons. This big long piece is the axon, which is surrounded by the myelin sheath. I'm not making that up. When the dendrites pick up a signal, it is transferred down the axon to the terminal buttons here. The myelin sheath helps the signal transfer down the axon faster. Now, to understand how neurons communicate with each other, we're going to have to zoom out a little. Now we have 2 neurons. The gap in between them is called the synapse. If this neuron fires, its signal is going to be passed from the cell body down the axon to the terminal buttons. The rest of the process will focus on the synapse. The terminal buttons, upon receiving this signal, release chemicals called neurotransmitters. The neurotransmitters go through the synapse to the dendrite and try to find a receptor site that fits them. Once a neurotransmitter connects to a receptor site, it releases its signal into the site and into the dendrite. The signal is then passed through that neuron, and it continues. When a neurotransmitter connects, it causes a physiological response that affects your brain in ways such as behavior, movement, and sensation. Each type of neurotransmitter does different things, but some can have multiple effects. After the neurotransmitter has connected, if it continues to float around in the synapse, it will connect again and cause too much of that response. There are 2 ways this is prevented: degradation, which is when enzymes from this neuron will break up the neurotransmitters until they're inactive, and reuptake, in which this neuron absorbs the neurotransmitters back in. So what is the happy chemical? What is the neurotransmitter that causes all joy, pleasure, and feelings of satisfaction? Well, the answer isn't so simple. There's actually 2 neurotransmitters that are considered the source of all joy: serotonin and dopamine. Let's go over each of them individually. Dopamine is responsible for feelings of pleasure. And while yes, that does include sex, it can also be other things like exercise and eating. Eating your favorite food, watching your favorite TV show, or even giving a hug to a friend can spark dopamine. When someone develops an addiction to a drug or an activity, it's because of the dopamine it produces. Your brain can never get enough dopamine, it will always want more. So when you find something that causes it so painlessly, it's really easy to get hooked on it. And then once you start to build up a tolerance, you'll need more and more just to feel the same amount of dopamine. But aside from pleasure, dopamine is also responsible for voluntary movement. So low levels of dopamine can lead to disorders like Parkinson's disease, which is characterized by violent tremors. Tremors happen when your brain has a hard time controlling its movement, and so you seem shaky. High levels of dopamine can lead to things like schizophrenia, which is characterized by disorganized thinking, abnormal movement, and delusions. Because these 2 disorders are related to the same neurotransmitter, medications for Parkinson's can cause schizophrenic symptoms, and the other way around. Moving back to serotonin. If dopamine is responsible for causing pleasure, then what does serotonin have to do with any of this? Well, I'll tell you. Serotonin is the most important neurotransmitter when it comes to stabilizing your mood. It affects your sleep patterns, your eating, and your general happiness. Because of this, low levels of serotonin can be related to depression and anxiety disorders. The most common medication to take for these disorders are called SSRIs, or selective serotonin reuptake inhibitors. Remember this? After the neurotransmitter connects, it will either get destroyed by enzymes or absorbed back into the neuron it came from. SSRIs prevent reuptake, so these neurotransmitters stay in the synapse longer and can connect again. This means that even if you have low serotonin, it will connect multiple times, causing you to feel like you have more. There are many other types of neurotransmitters besides those two, but I'm afraid we've come to the end of our time. So just remember, your brain can never get enough dopamine. So scientifically speaking, you will never be satisfied.